Hi guys, so today we're going to be looking at another topic on mechanics. So this is the last chapter on the AS mechanics, the variable acceleration. Okay, so first of all there's 4 questions for you here. It's a prior knowledge check, so you guys pause the video and have a go at this. Here are the answers. Okay, so moving on. So up to now you've been dealing with constant acceleration. So when you have a constant acceleration, the first thing to do is obviously just think about suva, because the acceleration is constant throughout. But if the acceleration of a moving particle is variable, then it changes with time and is therefore is a function of time. Velocity and displacement would also therefore be functions of time. So if we look at the graph to the right shows an example of increasing and decreasing acceleration. A body moves in a straight line such that its displacement s meters from the point O at time t second is given by s equals to 2t cubed minus 3t for t greater than 0. We've been asked to find the value of s when t is equal to 2. Find the time taken for the body to return to O. Now if we substitute t equal to 2 and we calculate, we get s equals to 10. Now, for the time taken for the body to return to the origin, well, for something to return, since we're dealing with displacement, we could set s equal to 0. Because remember, s is not the distance, it can be used as a displacement. So if we set the displacement 0 and then factorize, we could take the t out, and one of the solution, obviously t would be equal to 0, and then the other solution would be 2t squared minus 3 equal to 0. Okay, so if we divide it by 2 and then square root it, we get our t value to be 1.22 seconds. And now the clue with this type of question, whenever you're asked to find the time it comes back to the origin, you should always get one of the t values to be 0. Because at the beginning the displacement is 0, and after some second it's back to 0. So that's how you know if you've done it right or not. A toy train travels along a straight track, leaving the start of the track at time t equal to 0. It then returns to the start of the track. The distance s meters from the start of the track at time t second is modeled by s equal to 4t squared minus t cubed, where t is between 0 and 4. So we're only focusing between 0 and 4 seconds. Explain why there is a time restriction on this model. Since the track is straight and the train starts from one end, s must be greater than or equal to 0. So if s is greater than or equal to 0, 4t squared minus t cubed must be greater than or equal to 0. And then if you factorize that, we get 4 minus t. We know one of the t squared is 0 or greater. Okay, and the other option is 4 minus t greater than or equal to 0. So that means t must be less than or equal to 4. So the value of t must also start at 0. The negative time does not make any sense in this context. Okay, so a body moves in a straight line such that velocity v meters per second at time t second is given by v equal to 2t squared minus 16t plus 24 for t greater than or equal to 0. We're been asked to find the initial velocity, the value of t when the body instantaneously at rest, and the value of t on the velocity is 64 meters per second. The greatest speed of the body in the interval between 0 and 5. So for the initial velocity, we simply substitute t equal to 0. We calculate, and that gives us 24 meters per second. So whenever an object comes to a rest, the velocity would always equal to 0. Because if the velocity is not 0, then it's not stopping, it's carrying on going. So you set velocity equal to 0, get yourself a quadratic. We simplify it by dividing it by 2. We factorize, and that would give us the t value, t equal to 2 or t equal to 6. So to find the value when the velocity is 64, we simply replace the v with 64. We subtract 64 to make it equal to 0. Okay, so now you could divide it by 2 to simplify this quadratic. And then if we simply factorize, it give us t is equal to 10 seconds. And the t equal to minus 2, well, time cannot be negative, so we know that's the only solution, t equal to 10 seconds. So the next part, the greatest speed of the body between 0 and 5 seconds. Well, we could easily do a sketch here to assist us. So we know this is a quadratic, and we're only drawing it from t0 or more. It will look something like this. So if we cut it off at t is equal to 5 seconds, we're only interested in between 0 and 5 seconds. So you can clearly see the greatest speed will be 24 meters per second. So the super equation can be used when acceleration is constant and particle is moving in a straight line. If the acceleration of particle varies, you need to use calculus. So displacement, we call it x. Velocity is the rate of change of displacement with respect to time. Therefore, differentiating displacement gives velocity.
Yep.
The acceleration is the rate of change of velocity with respect to time. Therefore, differentiating velocity gives us acceleration. So in reverse, we use integration. So if you integrate acceleration, you should get velocity. And if you integrate velocity, you will get displacement. Particle P is moving along the x-axis at time t second. The displacement x meters from O is given by x equal to t to the 4 minus 32t plus 12.
X equals t. Okay.
We've been asked to find the speed of p when t is equal to 3, the value of t for which p is instantaneously at rest, the magnitude of acceleration when t is equal to 1.5. So for part A, since we're looking to find the speed, we've got displacement, we simply differentiate x with respect to t. So dx dt is equal to 4t cubed minus 32. Dx dt is the velocity, so we could replace that with v. So v equal to 4t cubed minus 32. We substitute in t is equal to 3. So we're going to find the speed when t is equal to 3. We calculate, and that gives us v equal to 76 meters per second. So here we asked to find the value of t for when this comes to rest. Well, same as before, for it to come to rest, the velocity would equal to 0. So we set v equal to 0, and then we add 32, divide by 4, and if we cube root this, t would equal to 2.
Yep.
So for the next part, to find the acceleration, we're going to differentiate the velocity. So dv dt will give us 12t squared, and then we replace dv dt with a, because differentiation of velocity with respect to time is the acceleration, and we simply replace the t with 1.5, and that would give us the acceleration 27 meters per square second. So let's look at this example here. A child is playing with yo-yo. Yo-yo leaves the child's hand at time t is equal to 0 and travels vertically in a straight line before returning to child's hand. the distance in meters s of the yo-yo from the child's hand after time t seconds is given by s equals to 0.6t plus 0.4t squared minus 0.2t cubed. So we're looking at t between 0 and 3. A. Justify the restriction of the time between 0 and 3.
Justify the restriction.
And for B, we're going to find the maximum distance of the yo-yo from child's hand to 3 significant figures. So usually what we're going to do with this is do a sketch of the graph to find the roots and the y-intercept. So first of all, the roots will be when s is equal to 0. So if we multiply by 5 and then factorize, there's t everywhere, and then we could factorize the quadratic. So in the graph we're looking at the roots at 0, minus 1 and 3. So a graph should look something like this. And we know it's a negative cubic. Okay, so now we have the graph. The maximum distance will be at the turning point. So the maximum distance, we know the turning point. By differentiating, we could set it equal to 0. So if we do ds dt, we get the following, and we then set it equal to 0. We multiply by 5, and then rearrange to get a nice quadratic like this. And then we solve the quadratic, and you can just plug that into your scientific class Swiss calculator, and it gives you t equal to 1.868.
So maximum distance.
So now we can sub into the original equation to find the maximum distance. Use the exact value from using the answer button on your calculator. If we substitute that in, that will give us s equal to 1.21 meters. So let's have a look at this one. A particle is moving on the x-axis. At time t is equal to 0, the particle is at the point where x equals to 5. The velocity of the particle at time t seconds, where t is greater than equal to 0, is 6t minus t squared meter per second. We want to find an expression for the displacement of the particle from O at the time t seconds, the distance of the particle from its starting point where t is equal to 6. So this time we need to do the reverse and do integration. So if we have a displacement, x would equal to integral of v dt. We can replace the v with 6t minus t squared. So now, if we do the integration, 3t squared minus t cubed over 3 plus c. Use the information of the question to calculate the c. So we're told the particle is at O at time t seconds. So c would equal to 5. Put this into the formula we have. So x equals to 3t squared minus t cubed over 3 plus 5. So to find the distance traveled by the particle at the time when t is equal to 6, we can replace t with 6 into x. We'll calculate, and it gives us x equal to 41. So this means that after 41 seconds, the particle is 41 meters from O. Note that it started 5 meters from O, so therefore 36 meters from the starting point. Read the question carefully. A particle travels in a straight line after t seconds. Velocity v meters per second is given by v equal to 5 minus 3t squared, t greater than or equal to 0. Find the distance traveled by the particle in the third section of its motion. We're going to sketch a graph to make it easier and clear for us. So v is equal to 5 minus 3t squared. We have a negative quadratic. So if we set v is equal to 0, we could work out the roots. So we got plus 1.29 and minus 1.2. So we obviously ignore the minus since t is greater than or equal to 0. So our graph would look something like this. So remember, the area under a velocity time graph is equal to the distance traveled. So first second between 0 and 1, second second between 1 and 2, and the third second between 2 and 3. So we could work out this area here, and you simply integrate between your limits 3 and 2. So once we integrate this, make sure you put your limits is a definite integral. If we substitute that in, we get minus 14. Well, clearly we could see it's going to be a negative because of the area below the t-axis. But since we're dealing with negative, the area, we simply write equal to 14. We ignore the negative. Be very careful on this type of question. If part of the area is above and part is below the x-axis, we need to integrate each part separately, ignore the negative, and add up the areas. So you might be asked to derive this formula on the exam. A particle moves in a straight line with a constant acceleration a meter per square second. Given that its initial velocity is u meter per second and its initial displacement is o meters, prove that the particle's velocity at time t second is given by v equals to u plus at. So you've all met these SUBAT formulas in the constant acceleration chapter, but you could be asked to derive this. And now we've learned calculus in pure maths, so we should be able to show this. We also want to find the formula for the displacement, s equals to ut plus half at squared. So the first thing you do is here, you know v is equal to a integral of a dt.
Yeah.
To integrate with respect to t, you'll get v is equal to at plus c. The velocity at time t is equal to 0 is u, because that's the initial velocity. So we could replace the v with u at time t is equal to 0, so replacing t with 0, so that will give us c equal to u.
Yeah.
And then once you get your c, you can rewrite this as v equals to u plus at. Now for the displacement, to get displacement we integrate velocity. We have a relationship from a, so we could replace v with u plus at. And if you integrate with respect to t, s will be equal to ut plus at squared over 2 plus c. When t is equal to 0, s equals to 0. So if we substitute this information in and calculate c, c is equal to 0.
Yep.
We can therefore remove the c from the formula above, and we will get s equals to ut plus half at squared.